Good evening, students. I welcome you all to my online class on numerical analysis. In last class, I explained the bisection method to find out the solution of a polynomial or all transcendental equation. So today we are going to solve few problems based on bisection method. So let's start with the first problem. So just to see the instruction, find a root of the equation x cube minus x minus 1 is equal to 0 using bisection method correct to two decimal places. That means we have to find out a solution of this equation using bisection method. So if you see nicely, see this equation, this one is a cubic equation. This equation has three roots or three solutions, but we are interested to find at least one solution of this equation using bisection method. So how to deal with the problem, that means how to apply the numerical method to find out the solution of this by bisection method. So first we have to write down the given equation. So see the given equation, it is x cube minus x minus 1 is equal to 0. So first from this equation we have to write down the function fx. So here it's clear that we have considered in the bisection method fx is equal to 0. So fx means what? It is x cube minus x minus 1. Okay, now we have to find out two ordinates, but they are of opposite signs. So here you have to be very careful. We have to choose the value of a and b in such a way so that they must be very close. In that case you may get the solution of the equation within limited number of approximations. So see here, if I take x is equal to 0, then f of 0 is equal to minus 1. If I take f of 1, then also you'll get minus 1. So f of 0, f of 1, all will give you the negative value. So if you go that way, if you take 1.1, then also you'll get the negative value. 1.2, then also you'll get the negative value. Up to 1.3, you will get the negative value. But if you take 1.4, then the value of the ordinate will come positive. So here it's better to take this point closer, then you may get the solution within a few number of steps. So here I find out the value of f of 1.3. So value of this is what? It is minus 0.110. So this one is less than 0. Same way you find out the value of f of 1.4. So substitute the value of x is equal to 1.4 in this expression, then the value will get 0.344. So this one is positive. So one ordinate is negative, another one is positive. So product of these two is less than 0. So from this we can say that there must exist at least one root of the equation within the interval 1.3 to 1.4. Okay, now what you have to do? Now we have to take the help of method of bisection. So we'll find out the first approximation. So first approximation we denoted by x1. So how will you find out x1? So you know that is a plus b. So here what is the value of a? 1.3 and b is 1.4. So first approximation is given by 1.3 plus 1.4 divided by 2. Just you can take the help of the calculator to find out this value. So here you will get 1.35. So now you have to find out the value of f of x1. That means f of 1.35. So once you find out the value, see here in this case you are getting the positive value. Now what is the meaning of this? See, as because f of 1.35 is not equal to 0, so this value is not the root of this equation. So now we have to go to the next approximation. Now see, f of 1.35 is greater than 0, and here you just to see f of 1.3 is less than 0. So what is the meaning of this? Now we can say the root lies between what? 1.3 and 1.35. That means we are making the interval more closer. In first case, see the interval 1.3 and 1.4. So now the interval, you will get the root lies in this interval 1.3 and 1.35. So that way you are making the interval more closer. Okay, so now we'll go to the next approximation. So it is denoted by, say, x2. So how will you calculate x2? It is 1.3 plus 1.35 divided by 2. So you will get 1.325. So again you find out f of x2 means f of 1.325. So here you are getting a positive value and this is not equal to 0. That means this value is not the root of the equation. Now f of 1.325 is greater than 0 and before that you see f of 1.3 is less than 0. So what is the meaning of this? That means the root lies between 1.3 and 1.325. So the root lies in this interval. So now we'll go to the next approximation. So next approximation is it is the third approximation. So now just find out the value of x3 in the similar manner. Just to see how to get the value of x3. It is 1.3 plus 1.325 divided by 2. So you'll get 1.3125. Again you find out f of x3 means f of 1.3125. Now you'll get the negative value. So this is not equal to 0. That means this is also not the root of the equation. So that means, see here, f of x3, that means f of 1.3125 is less than 0. And before that, if you see the previous step, second approximation, see f of 1.325 greater than 0. So that means what? The root lies between 1.325 and 1.3125. Therefore, the root lies in this interval. So now we'll go to the next approximation, fourth approximation, x4. We can find out just to add this two value divided by 2. So you are getting 1.3188. So this way we have to continue the process. But here see one condition is given. We have to find out the root of this equation using bisection method correct to 2 decimal places. So if you see the third approximation, see the value 1.3125. So after decimal you see the 2 digits, see here 1 then 31. So here also if you see after decimal 31. So that means the values of x3 and x4 are same, correct to 2 decimal places. So in that case here we can stop the process as per instruction given in the question. So what we can write, since the values of x3 and x4 are same, correct to 2 decimal places, therefore the root of the equation we can consider as 1.31. So this is one of the root of the equation, but this is the approximate root of the equation. So using numerical method we can find out the approximate root of the equation. So you have to be very careful about the instruction given in the question. If you are asked to find out the answer correct to 2 decimal places, so if in 2 consecutive steps if the values are same after decimal 2 digits, that means here 1.31, here also 1.31, that means after decimal 2 digits are same. So in that case you have to stop the process there only. Okay, now let me explain the next problem where we have to solve the equation using bisection method correct to 3 decimal places. So see the next problem, almost similar type. Find the root of the equation x cube minus 4x minus 9 is equal to 0 using bisection method correct to 3 decimal places. So exactly same way we have to proceed. So first we will write down the given equation. So here fx is equal to x cube minus 4x minus 9 is equal to 0. Now here fx is what? X cube minus 4x minus 9. So now we have to find out 2 ordinates, but they are of opposite signs. So if you consider say x is equal to 0, 1, 2. So in all the cases you will get the negative value. So up to 2.7 you will get the negative value. But if you take 2.8 you will get the positive value. So here you have to be very careful. You can take f of 2 and f of 3 also. F of 2 will be negative and f of 3 will be positive. But here it's better to take this point closer. In that case you may get the solution within a few number of steps, or after doing 3 or 4 approximations you may get the solution of the equation. So here I have considered f of 2.7. So how to find out this? In place of x you write 2.7 and with the help of calculator just simplify, you will get this value minus 0.117. This is less than 0, and you find out f of 2.8, you will get the positive value. So f of 2.7, f of 2.8, product of these two is less than 0 means what? That means there must exist at least one root of the equation within this interval. So now calculate the first approximation. So first approximation, you know, it is denoted by x1. So just to add 2.7 plus 2.8 by 2, you will get 2.75. Okay, now next you have to find out the value of f of x1. So what is the value of f of x1? So f of 2.75 you are getting 0.7969, so this is non-zero, that means this is not the root of the equation. So here f of 2.75 is greater than 0, and you see here, and f of 2.7 is less than 0, therefore the root lies in 2.7 and 2.75. So next approximation, find out in the similar manner. X2 is given by this. Again find out f of x2. This is not equal to 0, greater than 0. So f of this value is greater than 0 and f of 2.7 is greater than 0 means what? Now the root lies in the interval 2.7 and 2.725. So next third approximation, find out in the similar manner. So this is also not equal to 0, but you have to be very careful. See, after decimal 3 digits must be same in 2 consecutive steps, then you have to stop the process. So next you find out the fourth approximation, x4 you are getting 2.7063, and see f of 2.7063 you are getting negative value. Now we can say the root lies between these two values, 2.7063 and 2.7125. So in the fifth approximation, x5 we can find out just to add these two and divide by 2, you will get this value, and f of x5 is also non-zero value, so this is greater than 0. So that means the root lies between 2.7094 and 2.7063. So root lies in this interval. So next approximation, sixth approximation, you see 2.7079. So next, after this, the seventh approximation, when you find out the seventh approximation, x7, you see you will get this value 2.707, and you see just the previous approximation, sixth approximation, these two values are same, correct to 3 decimal places. See here 2.707, so here also see 2.7071. So after decimal 3 digits are same, and before decimal also here 2, in the previous case also 2, so we can stop the process. So what we can write, since the values of x6 and x7 are same, correct to 3 decimal places, therefore the required equation, required root of the equation is what? 2.707. So this way you will get the approximate root of the equation using bisection method. So these two problems, problem number 1 and 2, we have considered the algebraic or polynomial equation. Now let me take one transcendental equation and show you how to apply the bisection method to find out the root of the transcendental equation. So let's see the next problem. Okay, using bisection method, find the root of the equation 3x minus log x minus 6 is equal to 0, correct up to 2 decimal places. So see, this equation is a transcendental equation because here logarithmic function is present, and logarithmic log of x contains infinite number of terms. Okay, now we are interested to find a single root of this equation. So how to proceed? First you have to write down the given equation exactly same manner. Then you write down the function f of x is equal to what? It is 3x minus log x minus 6. So here log x is the common logarithm. That means the base of the logarithm is 10. So same way, find out two ordinates, but they must be of opposite sign. So after, if you calculate with the help of calculator, so after f of 2.1 you will get the negative value. Before that also f of 0, f of 1, f of 2 you will get the negative value. But if you say f of 2.1, this is negative, but f of 2 is positive. So it's better to take the values of a and b closer. So I have taken f of 2.1, this is negative value, and f of 2.2, this is positive value. That means the root lies between these 2 points. That means root lies in the interval 2.1 to 2.2. So in the similar manner, first take the first approximation x1, you will get 2.15. So f of x1 means f of 2.15, you will get the positive value. So now we can say, see, f of 2.15 is positive, and before that, say f of 2.1 is negative. That means the root lies between what? 2.1 and 2.15. Okay, then the next approximation, second approximation, you see it is x2 is equal to what? 2.1 and 2.15 divided by 2.125. Next you find out f of x2, that means f of 2.125. This is again C positive value. So now the root lies between what? 2.125 and 2.1 because f of 2.1 is negative. So next approximation is third approximation. See, you will get 2.113 and f of 2.113, see we are getting positive. This is not equal to 0 means this is not the root of the equation. That means the root lies between 2.113, this is positive, and before that you see at 2.1 is negative, so the root lies in this interval. Now next approximation is fourth approximation. Find out x4 again you will get 2.107. Find out f of x4, you will get the positive value. So now we can say again the root lies between 2.1 because f of 2.1 is negative and f of 2.107 is positive. That means the root lies between 2.1 and 2.107. So next approximation is the fifth approximation, x5, we will get this value. So if you see the values of x4 and x5, these two values are same, correct to two decimal places. See 2.10, here also 2.10. Now you have to stop the process. So since the values of x4 and x5 are same, correct to two decimal places, hence the required root of the equation we can take as 2.10. So this is the approximate root of the equation. So this way we can take the help of bisection method to find out the roots of an algebraic and transcendental equation. Hope it is understandable. So see you in the next class.